section number 39 is entitled Word Problems Involving Fractions. Like always, sometimes you don't really have to use algebra to do a problem. If I tell you that a number, now this is not the number A, it's the word A. A number plus its reciprocal is 5/2. Find their number. Well, this happens to be very simple because 5/2 is 2.5, which is 2 plus a half. If I call that the number, let n equals 2, well then, that's its reciprocal. Or, if I let that be n, a number plus its reciprocal. The reciprocal of this is 2. And just like 2 plus a half is 5 halves, a half plus 2 is 5 halves. And there are your two answers. You didn't have to do any work other than to realize that 5.5 was 2 plus a half. That's like the free problem. You don't always just go, boom, let's just go tackle this problem and solve it. Sometimes you just have to look at it from different angles, and it becomes very simple. 2.5 is 2 plus a half. For example, 5 plus a fifth. 5 1/5, which is 26/5. Instead of 5/2, if I said a number plus its reciprocal is 26/5. If this was my problem, first I would think that I would write it as a mixed number, 5.5. And I would say done, 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 5 plus a half. There's a number, there's the reciprocal, and I get 26/5. Or, here's a number, and I'm adding the reciprocal, and I get 26/5. So the answer will be 5 or a half. But, since this is an algebra class, let's use algebra. But there's a nice problem that can save you, here's a nice problem, the one on the board, that can save you a lot of time on an exam. I call this a non-problem. You don't have to do anything. But let's work it out. Let n equal a number. A number plus its reciprocal. This is understood to be n/1. There's the reciprocal. And this is equal to 5/2. So our goal is to get rid of the denominators. The denominators are n and 2. The least common denominator will be 2n. You need to kill off the 2 and the n. You multiply, or at least you denote you're multiplying each term by 2n. And the nice thing about 2n is n goes into it 2 times, and 2 goes into 2n, n times. And what you're left with is 2 times n, or 2n squared, plus 1 times 2, which of course is 2, equals 5n. Now, 2/2 is always 1, but n/n, you have to remember, n can't be 0. And this is the equation you need to solve. It's a quadratic equation. To get it equal to 0. Bring the 5n over. Now, since all these numbers are not divisible by 2, 5 is not, we can't really divide by 2. So you're going to try to factor by grouping. You multiply those two numbers, you get 4. And you look for two other numbers that also multiply out to 4, but add up to -5. The answer is -4 and -1. Unfortunately, two negative numbers. So you rewrite this equation, except you break down the -5n into -4n minus 1n. So you have 2n squared minus 4n minus 1n, plus 2. Minus 1n plus 2 equals 0. So you group the first two, and then you have minus, and when you group the second two, the 1n plus 2, you have to remember, since there's a minus in the middle, you have to change that plus to a minus. And when you factor the first bracket, you pull out our 2n, and you're left with n minus 2, which I'll fix in a moment. You're left with n minus 2 minus, and you have to factor out something from the n minus 2, pull out a 1. Now, I know I'm doing this right because these are the same. So you factor it out, and what's left over is 2n minus 1. 2n minus 1, which is 0. So either n is 2, or if you solve the next one, 2n minus 1 equals 0, you find that n equals 1/2. And those are the two numbers we had. N can be 2, and the reciprocal would be 1/2. Or n can be 1/2, and the reciprocal would be 2. So the answer is n equals 2 or n equals 1/2. But we already had that 10 minutes ago, because we realized that 5 over 2 was 2 plus 1/2. 1/2 being the reciprocal of 2. Now here's another very nice problem. If you add 3 to both the numerator and denominator of a fraction, the resulting fraction, the one you obtain after you add 3 to the top and the bottom, the resulting fraction is, say, 3 over 4. And you also know, and in the original fraction, the numerator is 3, I think 2 would be better, is 2 less than the denominator. Is 2 less than the denominator. So let's write down the original fraction. The numerator is 2 less than the denominator. So let x be the denominator, and the numerator is 2 less. That's the original fraction. But then we come and we add 3 to the top and the bottom, which gives us x plus 1 over x plus 3. And this is 3 over 4. This is 3 over 4. Now, there are two ways to proceed from here. The easy way, the hard way. Now, if you think of the numerator and the denominator, you'll see that the denominator is 2 more. If you have x plus 1, the numerator, and you add 2 more, you'll get x plus 3, which is the denominator. That is, the denominator is 2 more than the numerator. Here's the numerator, I add 2 to it, and I get the denominator. If only this had that same pattern, the denominator is 2 more. The denominator is only 1 more. So, I multiply by 2 over 2, because 1 times 2 is 2. Now their difference will be 2. So, x plus 1 equals 6. X is 5. To the bracket, it works in the bottom too. X plus 3 equals 8. X is 5. No cross multiplying, no solving linear equations. Well, we did solve x plus 1 equals 6. X is 5. X is 5. Okay, if the differences are the same, 8, the bottom is 2 more than the top. 8 is 2 more than 6, and the same thing over here. Whenever you have that, it's always going to be just solve x plus 1 equals 6, or solve x plus 3 equals 8. Now for the record, if you solved it right here, if you said, oh, x plus 1 is 3, you'd be wrong, because that means x is 2. But when you go to the bottom, 2 plus 3 is not 4. Remember, x can only be one value. That is where I got the difference between the top and the bottom to be 2. Initially, the difference was 1. The bottom, 4, was 1 more than the top. So I doubled it. And now the difference is double. It is now 2 times the original difference, which was 1. 2 times 1 is 2. So then you just said the numerator is equal to one another, or the denominator is equal to one another. In the end, x is 5, so I'm going to come back to the original problem, the original number. And if x is 5, I say 5 minus 2 is 3, and the bottom is just 5. That is the original fraction. And yes, the denominator is 2 more than the numerator. And due to space, I'll write here, if I add 3 to the top, 3 plus 3 is 6, and I add 3 to the bottom, 5 plus 3 is 8, I do get, after reducing, 3/4. Okay, so that is the right answer. But let us do it the long, hard way. Not exactly clear why one would want to, but let's do this. So after adding 3 to the top and to the bottom, we get x plus 1 over x plus 3, and we are told this is 3/4. Well, we have to clear out the denominators. Let us multiply both sides by 4 times x plus 3. 4 times x plus 3. Don't tell me we're going to get 2 answers. No, we won't. Okay, well, on the left side, the x plus 3's cancel, so we get 4 times x plus 1, which is 4x plus 4 equals, here the 4's cancel, and you get 3 times x plus 3, which is 3x plus 9. I'll bring all the x's to the left side, which means I'm bringing the numbers to the right side. The left side we get 1x, and the right side we get 5. The x is 5. Come back to your original number. X minus 2 over x. 5 minus 2, well that's 3, and x is still 5. The answer is 3/5. That's the original fraction. Get the difference between the top and the bottom to be the same. You had x plus 1 over x plus 3. The difference is 2. So let us look at a similar problem. I'll put you right in the middle. If you have x plus 2 over x plus 8, then this is equal to 4 over 7. Now, there's absolutely no reason to say, oh, x plus 2 is 4, so x is equal to 2, because that doesn't work in the bottom. 2 plus 8 is not 7. But what you can do, and this really makes your life easier, what you can do is say, this bottom number, x plus 8, is 6 more than the top number. If you take the numerator and you add 6 to it, you get the denominator. The denominator is 6 more. But in this fraction, the denominator is only 3 more. If you take the numerator and you add 3, then you get the denominator. 3. 3, but I want 6. The denominator is 3 more, but I want it to be 6 more. Oh, I'll double this 3. 3 times 2 is 6. So 4 over 7 is the same as 8 over 14. Now the bottom is 6 more. So now what I can say is these numerators are equal. These denominators are equal. X plus 2 is equal to 8. So now I know x is 6, and that's done. You don't have to clear out the denominators. You just double numerator and denominator. Since I always seem to be multiplying by 2 over 2, let us change that real quickly. That is, let's look at another problem. Suppose I have x plus 3 over x plus 18. It's 15 more at the bottom. The bottom is 15 more. Well, if I tell you this is equal to 7 over 12. Now, this bottom is 15 more than the top. I would love for this bottom to be 15 more than the top. Because if they are, I'll set the tops equal, or I'll set the bottoms equal. But you know what? It's only 5 more. This bottom is only 5 more than the top. 5 times 3 gives me 15. So we multiply top and bottom by 3. So I get 21 over 36. This bottom is 15 larger, so is this. So we equate the numerators. X plus 3 is 21. X is 18. If somebody asks you to solve this problem, it's a lot easier to do it that way. Now, there is one case where it may not be so friendly to do. For example, what's going on? In the left fraction, we have the denominator being 15 more. Okay, and suppose I have 2 over 5. And I don't like that one. 2 over 9. I have 2 over 9. Suppose you have that. Now, this denominator is 15 more than the numerator. 15 more. This is only 7 more. Well, what do you multiply 7 by to get 15? You can solve that. 7 times what equals 15? The answer is 15 over 7. So now you multiply top and bottom, believe it or not, by 15 over 7. You get 30 over 7 over 135 over 7. This bottom is 105 over 7 bigger. But you know what? That's 15. That's 15. So then, last thing is you set the numerator is equal, for example, or the denominator is equal. You say x plus 3 is 30 over 7. Now, on the left side, it's favorable to write minus 3. You take away 3. On the left side, it's more favorable to write that you're taking away 21 over 7, which is also 3. That's 3. It's just another way of writing 3. And in subtraction, the denominators are the same. 30 minus 21 is 9. And there's your answer. Okay, if you didn't like that one, fine. But I do want to review one more thing that just came up. Students know how to say solve linear equations. But you need to know how to write down one. If you need to know, for example, 3 times what is 11? 3 times what equals 11? If somebody asks you 3 times what equals 11, first of all, you're not supposed to say nothing, because the answer is nothing. 3 times no number is 11. Because that's not true. If you divide by, so you need to be mathematically sure enough to say 3, or to write 3 times what equals 11. And if you divide by 3, you found out what x is. Now, it's one thing to know how to solve this equation. It's another level of understanding to know what it is that you solve. What does it mean x is 11 over 3? Well, that's the answer to the question. 3 times what is 11? 3 times that number is 11. After all, the 3's cancel out. 3 over 3 is 1. And 1 times 11, yes, 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 that's 11. 3 times what equals 11? 11 thirds. Okay. Next problem. And this is an excellent problem that we're going to do because it might really come up in everyday life. You and your friend, mostly your friend, she wants you to drive her to the ballpark. There's a big baseball game, and she wants to see the game. And it turns out that to go to the baseball game, you must. There's no way out of it. You must leave by 12 minutes. Okay, you can't leave a minute after. If it's 12:01, your friend's going to say, don't bother taking me. Okay? But you have to paint a room in your house. You must paint your bedroom. Your bedroom prior to going to the game, the ball game. Okay? You will start at 9 a.m. That's the earliest you can start. You will start at 9 a.m. But it takes you 5 hours to paint the room. To paint the room, working alone. So your friend calls you up and you tell her, look, friend, I'm getting home late from work tonight. I'm going to go to sleep. At 9 a.m., I'm going to wake up, and I have to paint my bedroom. And it's going to take me 5 hours. And I know we have to leave at 12 o'clock to get to the game, so I'm letting you know I can't take you to the game. But your friend really wants to go to the game. Your friend tells you the following. Your friend says that she will come by at 9 a.m. to help you paint. Help you paint the room, and it takes her 6 hours to paint the room working alone. Now, the question is if you're this friend, you have two options. First of all, you know that you have 3 hours, from 9 a.m. to 12 noon. And you know it takes your friend 5 hours, and it takes you 6 hours. But you only have 3 hours. So now, you have two options. You can come by at 9 a.m. and work up into at least 12 o'clock. I mean, if you finish before 12 o'clock, you finish and you go to the baseball game. And if 12 o'clock comes and you're not finished, well, you tell your friend, have a good day, I'm out of here. Or you can do the mathematics at home and know whether or not you should even bother coming. Okay, this is a for real problem, a real life problem. Your friend's a painter, and she knows it takes her 6 hours to paint the bedroom. And you also being a professional painter, you know it will take you 5 hours to do your bedroom. You have more experience than your friend, so you do it faster. Now, the thing is that you normally, you don't work with other people, so you can't say, well, I know 2 people can't do it in 3 hours. You do it in 5 hours, your friend can do it in 6 hours, working together. Will you finish in 3 hours? Okay, well, let's see. In 1 hour, let's talk about you. In 1 hour, you will complete, working alone, you will complete 1/5 of the job. We'll assume that you work steady. Each hour you do 1/5 of the job. In 1 hour, you will complete 1/5 of the job. In 2 hours, you will complete 2/5 of the job. In 3 hours, you will finish 3/5 of the job. In 3.5 hours, you'll finish 3.5 over 5 of the job. In T hours, you will complete T over 5 of the job. Okay, your friend, E-N-D, in 1 hour will complete 1/6 of the job. In 4 hours, she will finish 4/6 or 2/3 of the job. In 5 hours, she will finish 1/6 of her job. In T hours, she will finish T over 6 of the job. So together, in T hours, yeah, let's just do it that way. Together in T hours, you will complete the sum. You will complete 2 over 6. Well, I meant to write T over 5 first, but it doesn't matter. In T hours working together, you will complete T over 6 plus T over 5 of the job. This is how much work you will do in T hours. The question is, what do you want this to equal? This is how much work you do in T hours. That's the part of the job you do in T hours. Well, you want it to be one complete job. You want it to be one complete job. You want to find the T that will make that one complete job. For example, if T was 1, you did 1/5 plus 1/6 of the job, which I think is 11/30ths of the job. That's if T was 1. If instead of setting it equal to 1, we set it equal to 11 over 30, it would turn out that T was 1. But I don't want it to be 11/30ths of the job. I want to complete one whole job. Alright, so this is the equation you have to solve. The LCD of 5 and 6 is 30. That's the first number that 5 and 6 both go into. So let me write 30. That's the first number that both 5 and 6 go into. 5 goes into it 30 times, so you have 6t plus t times 5 is 5t equals 30. Then you have 11 t's equals 30. So t is 30 over 11, which is less than 3. 11 goes into 30 2 times with 8 left over. It will take you 2 and 8/11 hours. Okay, your friend can go home and work this out at her leisure and conclude that it's less than 3 hours. Less than or equal to 3 hours. Because if it takes 3 hours, you will be done exactly at 12 o'clock and you leave for the baseball game. It takes less than 3 hours, so your friend should come by 9 o'clock in the morning and help you paint. And she will know for sure, yep, we're going to the game. There's no doubt in my mind we are going to the game. Now, how might you do this a lot more quickly? Well, you always take T, and it takes one person 5 hours to do it, plus in the same T hours, it takes the other person 6 hours, and you want it to equal 1. And you solve that. And when we did solve it, we got T is equal to a number less than 3. Less than 3, that's the key number. Takes more than 3 hours, you don't put it in the game. Now, let's modify this a little bit. Your friend cannot come by at 9 a.m. Your friend's coming by at 10 a.m. So you are going to work T hours, and it takes you 5 hours. Your friend, she is going to work 1 hour less. And working alone, it takes her 6 hours. You add them up and you want to get one full job. So, just like before, to clear out their denominators, to multiply So I'm going to denote that I'm multiplying them by good old 30. And we pick 30 because 5 goes right into it. And you get 6t plus 36 goes right into 35 times. Positive 5 times t is positive 5t. And positive 5 times negative 1 is negative 1. Excuse me. Negative 5. And the right side is 30. Well, this must be 35. 35 minus 5 is 30. Bring the 5 to the other side. We'll see that. What's in the box is 11t. And when you bring 30 to the other side, it becomes 35. And all I care about is 3. That's all that's in my mind. 3 hours. 11 times 3 is only 33. So it'll take more than 3 hours to finish this job. T, excuse me. T was the length of time it's taken the person who starts at 9 a.m. And this is where it falls apart. You get 35 over 11. 11 goes into 35 3 times with 2 left over. This takes more than 3, no baseball game. Okay, if your friend can only come at 10 o'clock, not at 9 o'clock, your friend should not come. It's not in her best interest to come. Her goal, this is the assumption, her goal is really not to help you paint your room. The goal is to help you be ready to take her to the ball game. That's all she cares about, getting to the ball game. Okay, if that means she has to help you paint your room, not a problem. But if you're not going to take her to the game, she doesn't want to help you paint your room. Alright, so here's a case where knowing algebra could help you. Now, for people who don't know algebra, they would just get up and come to help you, and if it doesn't work, they say, oh well, and if it does work, they're happy. But they didn't even realize they could have used algebra. Okay, let's do another problem. You have this very, very large container. You need to fill the container, the empty container, with water. Working alone, it will take you 2 hours to do. Your friend can do this job alone in 3 hours. How long will it take you working together? How long will it take you working together? Now, a lot of students say, oh, this is real simple. It takes me 2 hours, it takes my friend 2 hours. We find the average, which is 2.5. Now, you need to think, it won't hurt, but students say answers that are obviously wrong, and it's because they're not thinking. Of course, this is the wrong answer. If you work alone, you can do it in 2 hours. 2.5 is more than 2. If that's the case, you better tell your friend, please don't come. It's going to take me more time. But that's not true. If your friend does how long it's going to take you to finish your job. Okay? Assuming you guys don't get in one another's way, it will always be faster doing a job with two people. Well, let T be that special time it takes working together. Well, you're going to do T over 2 of the job, and your friend will do T over 3 of the job, and it needs to be 1. Remember, in say 1 hour, your friend will do, you will do 1/2 the job, and your friend will do 1/3 the job. In a half an hour, you'll do 1/2 over 2, 1/4. Your friend will do 1/2 over 3. It's always T, how long you work for, T, divided by how long it takes you to work alone. Now this is the problem we need to solve. And the LCD for these two fractions, that is, the LCM for the denominators is 6. The first common multiple is 6. So we multiply everything by 6. 2 goes into 6 3 times. 3 goes into 6 2 times. 3 times T plus T times 2, which is 2T, equal to 6. So 5 T's is equal to 6. And T is 6 over 5. It's 1 1/5 hour. It's 1 hour plus 1/5 of an hour. If you take the hour, which is 60 minutes, you divide it by 5, you get 12 minutes. That's 1/5 of an hour. Takes 1 hour, 12 minutes. That's how long it will take you and your friend to do the job. Okay, it'll take you under an hour and a half. Since your friend works slower than you, it'll take you more than, working together, it'll take you more than half the time. Half of 2 hours is 1 hour. This was more than 1 hour. Since your friend works slower than you are going to, normally if you both worked 3 hours, did the job in 3 hours, it would take you an hour and a half. You would do half, your friend would do half, it'll be done in an hour and a half. You do an hour and a half of work, your friend does an hour and a half of work, together you did 3 hours of work. But since you can do it faster than your friend, it should take less than 1.5 hours. And this number is less than 1.5. The answer should be between 1 and 1.5. Between half of this, 1, and half of that, 1.5. And that number is in between 1 and 1.5. Alright, now let's just finish up this section by modifying this problem a little. There is a hole in the can. There's a hole in it. There is a hole in this can. There's a hole in the can. There is a hole in the bottom, the very bottom. The bottom of the can. A full can will leak out completely. Will leak, L-E-A-K, will leak out in 8 hours. How long will it take you and your friend to fill the container? Well, you are going to add T over 2. Your friend is going to add t over 3. Your friend's going to work for t hours, and it normally takes her 3 hours to fill. You're going to work for t hours, and it's going to take you 2 hours to fill. You are contributing to filling the can, hence the plus. The leak is removing water. Okay, we are taking out water. Now, this imaginary third person, that you can, instead of there actually being a hole in the bottom, you could actually have a third person who takes water out. You and your friend pour water in, and the third person takes water out. Now, this person, it would take 8 hours to do their job, taking out the water. Now, is this third person, the hole, is this hole working the same t hours you're working? Well, the question is, the hole is always there, so is it working before you get to the can and start filling it up? The answer is no. The container is empty. When you and your friend arrive, the container is empty. If it wasn't empty, then I'd have to tell you how full it was. Well, assuming the container was empty. Now, the hole is not working when it's empty. No water is pouring out. The water is only pouring out when there's water in there. And water is only going to be in there for the t hours that you and your friend are working. Okay, it's going to be t. And you are going to get one full job. Now, you're only concerned about filling the tank. At some point, that container is going to be completely full. And a second later, it's going to be less than full because the hole is continuing to work. But we don't care about that. We only care about how long it takes to fill the container. This is a problem you would have to solve, and the LCD, that is the least common multiple of 2, 3, and 8, is 24. So you multiply everything by 24, or you denote that you're doing that. Multiply everything. Thing means term. Terms are separated by addition, subtraction signs, and equal signs. And we pick 24 because 2 goes into it, 3 goes into it, and 8 goes into it. 12 times, 8 times, and 3 times. And then you get 12 times t, which is 12t, plus 8 times t minus 3t, which happens to be 17t, which equals 24. So t is 24 over 17. There's 24 over 17, which is 1 7/17 of an hour. Okay, close to 1.5 hours, a little bit less than 1.5. After all, you'd have to have 8.5 over 17 to have half an hour. But you only have 7. You don't have quite 8.5. So it's less than 1.5 hours. Okay, that completes this section and this video entitled Word Problems Involving Fractions. Good luck with it.